Hello folks, welcome back to EvolvNext, and our today's topic of discussion is data reshaping with pandas. In this video, we will have a look at how to reshape a data, that is how to merge two different data sets. Then we will have a look at what is wide format data, what is long format data, and then we will also see what is pivot and melt functions, and then we will also have a look at how to stack and unstack the data. So let's jump in. Our first line of code, import pandas SPD, as we already have done this before uh, on several occasions. Then I would like to show it to you that we have some sample data sets like movies, ratings, and NBA CSV sales data. These are the data sets we will be working on today, and we would see what are the various different outputs that we get when we perform various different joins when we try to merge the data. Now first I have loaded, or you can say I will read the dataset movies and ratings. So if you have a look at the um, movies dataset, and if you have a look at ratings dataset, you would see that there are two things. There is one thing in common, that is movie ID. On the basis of movie ID, we can definitely perform a join. Now, what is join? What is inner join? What is right join? So these come under the SQL concepts that you should be aware of to understand this video. All right. So I will, in the first case, join on the basis of inner join. To join two tables, here in Pandas, we have a function called as merge. You pass the name of the two tables, that is the left table and the right table, and you also have to mention on what column you are going to make a join, that is movie underscore ID in this case, and what kind of join, that is inner join, is something that you are going to perform here. So inner join, as we know, it displays the intersection part or the common part between the data sets. All right. So here you would see the output excluding movie ID 5, because movie ID 5 is there in the movies dataset. Look at this, but it isn't there in the ratings dataset. So you would not see that uh, movie ID 5. However, if you perform a left join, so whatever is there, I mean, all the rows in the left table should be displayed. Here in this case, the left table is a movie table. In movie table, we have these 5 rows. So accordingly, the 5 rows will be displayed and the intersection part as well. So you would see here in the output for left join, you would see here we have the common part as well as all the rows in the movies dataset. That's why you would see this movie ID 5. However, there is no data corresponding to the user ID and rating. That's why it is showing 9 over here. All right. And then moving ahead, on similar lines, we can perform right join as well, wherein all the rows from the right column will be considered and the output will be displayed accordingly. That's the reason you get such kind of a output. Then if you are aware of what is outer join, all the rows and columns will in the all the rows or columns that are there in both the dataset will be displayed, eliminating the duplicate values. All right. So this is the output for the outer join. So here what I have done, I've used same merge function and same syntax and just modified the way I am joining. So whichever join you want to perform, you have to mention in the parameter how. All right. So that's about how to join the particular data. Now there is one another data set called as sales data, and it looks like this, that it has product, region, month, and sales. Now say if I want to convert this into a wide format data. Okay, so what is wide format and what is long format data? Wide format has got a column for each variable. Like in this case, say Jan, month of Jan, or say Jan sales or Feb sales, they will be considered as individual columns in wide format data. However, in long format data, we try to compact them as much as possible, and whatever we see here on the screen, this can be called as a long format data. So in most of the real world scenarios, long format data is preferred over wide format. However, for doing some analysis, maybe you find that wide format is suitable, then you may very well go with the wide format as well. So here what we are looking at, how to pivot a particular data set. Here we have got two functions in pandas for doing that, that is pivot underscore table and pivot. So if you want to use some aggregation functions along with pivoting, so you might be better off with the pivot underscore table. All right. Otherwise, you can go for pivot function as well. So here, what I'm doing in this pivot underscore table function is I will be trying to make this February, January, whatever the columns were there earlier. All right. Sorry. Whatever was there in the month, whatever the value was there in the month column, that is February, Jan, or any month you listed down here. Here it is only two. That I will try and put it in one in separate columns. All right, that is, I will make a separate column for Jan, and I'll make a separate column for Feb, and I will calculate some aggregation. That is, in this case, I'm doing a sum. All right, that's the reason I get this kind of output. So your first thing, that is, you define what is the index that you want to keep. I have kept indexed as a product column as an index, and then columns month I am keeping is as it is. Then what I'm doing in that, values, I'm putting it as sales. All right. So whatever was there in the sales, I'm putting it in value, and then for the columns, I'm considering month, right? So month were January and February. That's the reason they are looking here as individual columns, because you mention here that columns, what columns you want, whatever is there in the month, that we want it as a column, and then you do a aggregation, that is some average, what some or average, whatever you want to do, you can perform, and then you would get an output of such kind that it will display all the months that are there in our data. It's only Feb and Jan, so it will display that as an individual column, and they will have their sum of sales for product A and sum of sales for product B, which will be individually shown. So if you are looking really for this kind of output, you may go with performing pivot using this pivot underscore table function. All right, and converting it back to what it was original, we have a med function, and I've also used reset index over there. Now, when you convert it back, you need to mention what are when you mention these parameters, that what you are up to. So in the whichever you want to um, put it as a column, then you have to mention it over here, that id underscore vars. That is one parameter where you can mention the product column name, and then value, what value you want, that is Jan and Feb. All right, value means earlier it was Jan and Feb, right? If it were all 12 months, I will have to put those values over there, because those are the values that will be coming repeatedly in the month column. And what is the name of that variable? That is month. And what is the value name? That is sales, because ultimately you want to look out for sales for a month and for that product. Here you are not doing any kind of aggregation, and you are as well trying to shrink, or you can say make a data in a long format. You want to compact the data, and that's why you are getting this kind of output. The aggregation still remains the same, because you are pivoting on you are menting on what data set, pivot underscore data set. It is not the original one. Here you have the same sales and the same output, but you want to see it in this format. That's the reason you melted it back again to the format that you prefer, that is long format. All right, this data has been melted back. It's not about the original data. Please note these things, don't get confused. It's pretty simple. This was the original data. We did a pivot. We converted it into this. However, we felt that maybe the preferred format should be this one, because this looks pretty good for analysis, and that's why in some cases it might be that might happen that you feel that this is the better one, then you may well go with this. There is no issue as such. All right, then moving ahead, we have one another small data set, that is nba.csv, where we have this columns: name, team member, position, age, height, weight, college, salary, and all these things. And we want to do a stack. So stacking again is making or converting a particular data into just hold on, let me run this again. Yeah, converting a particular data into a compact form. If you would see here, whatever was displayed in the rows, that is, say this is the first row, this entire thing got compacted into one single index and in one column. That is very important. And instead of showing it as one row, it got converted into one column and in a single index. Okay, so similarly, you can now also unstack things to get back to the original format. Again, it matters which format are you trying to prefer. It's a wide format or it's a long format. Okay, now as a formal definition, it says that compress columns into hierarchical index and turn them into rows. That is what stack does. All right, compress columns into hierarchical index. So this is what was done earlier. They compressed all the columns into a single column and they turned it into a hierarchical index. That for this one, what is the name, every Bradley, then what is the team, again the same hierarchy in the second row, again the same hierarchy in the third row, and so on, the entire data. All right, then unstack something is a reverse operation. If you want it back again in the format that it was there, so you were able to achieve that as well. That is in its original format. All right, so you simply use unstack for that. Now let's see what is the concept of like multi-level index. So for that, what we have done is we have prepared a small data frame over here which has got columns city, year, population, and area. Then what we have done is we have set columns city and year as a index. So this is how the data looks like when you set it as a index. Now you try to stack that data. If you try to stack, this is the output you get. All right, you use stack. There is a stack function to stack the data as we saw earlier, and this is how the data looks after stacking. So you would see why they're saying as a um, hierarchy or as a multi-level index, you would see here that new city and year, then that year again is divided into two. Okay, and uh, two, that is 2020 and 2021, and in 2020 again we have two different things, that those were columns earlier were converted here. So in 2020 what was the population and what was the area, in 2021 what was the population, what was the area. And this looks like a hierarchy, right? Because again for Los Angeles again it has its hierarchy, Chicago it will have its hierarchy. The data is not there for 2020 and that's why it isn't showing over here. Okay, but that's the importance, what kind of data and in what way you want to have a look at it, so that it will be helpful when you analyze it further or when you try to draw some plots or visualize it further. So it's all about what are the questions you are going to solve or what exploratory analysis you are going to perform. Depending on that, you have to shape your data first. After shaping the data, only then you can go for your desired outputs. All right, when I unstack it back again, it goes to the original format, that is the one displayed over here. Okay, so that's how stacking and unstacking works. See these concepts like pivot, melt, stack, unstack, wide format, long format, it's very important to know, because ultimately what is our end goal, to perform some kind of exploratory analysis on this and generate insights out of it, right? So the very important thing is that you inspect data properly. After inspecting the data, you perform whatever the uh, indexing or whatever the data filtration you want to do. Then you clean the data properly, transform your data as we have seen in our previous video, and then move on to reshape. Then combining all these three things, get the data in the format that you require, arrange it in such a way that it will be helpful in your analysis when you do visualization. So that's all about this video and pandas concepts. Thank you for watching. Have a nice time.